Nonetheless, a full description of MD4 is included in this algorithm that we talked before. Yeah. For historical and the cryptanalytic reference, it also serves as a convenient reference for describing and allowing in comparisons between other hash functions in this family. And if you open the book that in the MD5 hash functions, input bit string x arbitrarily bit length b larger than equal to 0. Output will be the 128-bit hash code of x. MD5 is obtained from MD4 by making the following changes. Here they replace the round of 2 function by g. You can see here in the define the round 4 function, it's the equal to these functions, and the definitions of constants redefine unique additive constants. First 32 bits of binary value, and where g is in radians and the abc denotes absolute value, redefine access order for words in round 2 and round 3, and define for round 4. And here you can see the 3 types of the Z divided with the bit number, redefine number of bit positions for left shifts, rotates also with the S symbol till the 64 bit, and also in the preprocessing as in MD4, in the processing in each of rounds 1, 2, and 3, replace B with this function by b with this function, also immediately following round 3 with this function. And in the completion as in MD4, you can see here how these algorithms work and how it's the this string turn to the hash value with the hex byte string, and with the MD5, as you see here, the bit length is the same, but for the SHA-1, bit length will be the more larger, and for the RIP-MD 160 also the bit length will be the larger, but longer, but it doesn't depend on the symbols. The bit length will be the same. You can see the for the this kind of types of the data. And also secure hash algorithms. It's the based on the MD4, was proposed by the US National Institute for Standards and the Technology. As we know, it's the NIST. For certain US federal government applications, the main differences of SHA-1 from MD4 as follows. First one, it's the hash value is the 160 bits, and the 32 bit chaining variables are used. The compression function has 4 rounds instead of 3, using the MD4 step functions f, g, and h as follows: f in the first, g in the third, and the h in the both second and the fourth rounds. Each round has 20 steps instead of the 16. Within the compression function, its 16 word message block is expanded into 80 word block by a process whereby each of the last 64 of the 80 words in the is the or of 4 words from earlier positions in the expanded block. These 80 words are then input 1 word per step. To the 80 steps, the core step is modified as follows: the only rotate used in is a constant 5-bit rotate. The fifth working variable is added into each step result. Message words from the expanded message block are assessed sequentially, and the C is updated as the B rotated left 30 bits rather than simply B. And also for the SHA-1 uses 4 non-zero additive constants, whereas the MD4 used 3 constants, only 2 of which were non-zero. The byte you're ordering used for converting between streams of bytes and the 32 bits words in the official SHA-1 specification is big endian. This differs from MD4, which is little endian. Also, MASH, it's the modular arithmetic secure hash algorithm 1, is a hash function used based on modular arithmetic. It has been proposed for inclusion in a draft ISO standard. MASH 1 involves use of RSA like modules M. This bit length affects the security. M should be difficult to factor, and for M of unknown factorization, the security is based in part on the difficulty of exacting modular roots. The bit length of M also determines the block size for processing messages and the size of the hash result. As a recent proposal, its security remains the question. Techniques for reducing the size of the final hash results have also been proposed, but their security is again undetermined as yet. Also here the MASH 1 algorithm, but it's not popular, but you should know about that. Input it's the data x with the input it's the data x with bit length b between the degree of 2 and the 0. And in the output, we will get the n-bit hash of x, and it's approximately the bit length of the modulus m. System steps setup and the constant definition, fix and the RSA like modulus m equal to q of bit length m, where p and the q are randomly chosen secret primes such that the factorization of the m is interactable. Define the bit length n of the hash result to be the largest multiple of 16 less than m. X0 equal to 0 is defined as this symbol for and the n-bit integer constant r is equal to this, and denotes bit size exclusive OR, and denotes the bit size exclusive OR, and the padding blocking and the MD stringing pad x with 0 bit if necessary to obtain a string of bit length t for the smallest possible t larger than or equal to 1. Divide the padded text into these bit blocks and also x data, and append the final block xt plus 1 containing the n divided 2 bit representation of b. For the expansion, expand each x parameterized by e to n bit block, y parameterized by e by partitioning it into nibbles and inserting for 1 bits preceding each except for yt plus 1, wherein the inserted nibble is 1010, not 1111. Compression function processing for the one lower than equal to e, but e lower than equal to t plus 1, map to n-bit inputs. Here the to 1 n-bit output as follows, and here we have this function of the output. Here the n denotes keeping the rightmost n bits of the n bit results to its left, and in the completion we have the hash in the n bit block with the t plus 1 parameterized. The MASH 2 is defined as per MASH 1 with the exponent e equal to 2. Use it for squaring in the compression function processing stage. Step 4 here, and here exponenta will be replaced with the 8 degree of 2 plus 1. Thank you for attention. Here, this lecture was about the mathematical background of the hash functions, unkeyed hash functions without the secret key. It's the MD4, MD2, MDC family.